Okay, yeah. Hi everyone. So we are happily inviting you the next AWS developer session. So in this session, we are going to discuss about AWS DynamoDB. Okay. So in the previous sessions, we discussed about how to create the sample application, um, how to build the sample infrastructure using AWS CDK, and then we discussed about how to build the Lambda application in CDK with the help of CDK, and then we discussed about API gateway. These are the services discussed about, and then to continue that in this session, we are going to talk about DynamoDB. Okay, so the agenda in this session is we are going to discuss about how DynamoDB stores the data in internally. Okay, and then what are the key concept it has, and then finally we are going to discuss about how to do the how to deploy the DynamoDB using AWS CDK, and then how to perform the CRUD operations, create, update, delete operation with the help of AWS SDK. Okay, so these are the things we are going to discuss about. So yeah, so generally, AWS DynamoDB is a serverless NoSQL databases which support multi availability zone. Okay, so we don't want to worry about the infrastructure management, like the server configuration. We don't want to worry about it. It's actually serverless service based on the load, based on the like the data uh, we are inserting into the database. It will scale by itself. Okay, so it's a distributed system. So like by itself the data is stored into the multiple nodes, so everything is handled by AWS. Okay, so it's not in the in-memory database. In-memory database means it's like storing the data in RAM. It is not like that. The actual data will be stored into the like some persistent devices. Okay, so data will not be lost at any time. And then the storage, it has inbuilt auto scaling functionalities based on the load and the network traffic, and then it can easily scale up and scale down by itself. And then the response time of each query, it's a single digit millisecond response. We can get it at any scale. That's one of the advantages of using DynamoDB. Okay, and another one feature we can talk about is for the particular cell, particular column, particular item, we can store maximum of 400 kp data. We can store it. Okay, and then uh, at the time of creating the table, we have to define our primary key. Okay, so primary key will help you to identify the data as soon as possible. Okay, so it will um, help you to query the data in a very easy manner. Okay, so in the primary key, we have to this is kind of default indexing approach. Okay, so in the primary key there are two options. It's there. One is the partition key, another one is sort key, that we will discuss about in the next one. So at the beginning of the level, we have to define our primary keys, and then we can set indexes also. Indexes are other than primary key. Some of the fields we can set it as for a querying, improving the querying performance. That index also we can set it, and then it provides time to live options also. The particular record, how long it can stay in our database, that's also we can set it. And then it supports transaction like operation also, it can support it. So whether you can write the transaction, write the operation in multiple tables, or you don't want to write the operation the any tables, that's also we can configure it. Okay, so and then other concept, okay, in the capacity wise, in the in storage wise, it's providing two options. One is provisioned mode and another one is on demand mode. So the first thing was provision mode is we have to define the read capacity of our database and write capacity of our database. We have to define it. Okay, which they are calling RCU and then WCU. Okay, so like based on that, our bill also will be generated. If the particular read capacity limit is reached, and then your write capacity limit is reached, we can get some warning cells like a limit exceeds exception, something we can get it will be thrown. So that is the one thing in provision mode. Okay, and another one is on demand mode. So it's actually pay for what you use based on the workloads. It can easily auto scaling. Okay, so it's great for unpredictable workloads. We can choose for on demand modes, we can choose it. Okay, so and then The next concept, other key concepts are other key concepts are basically it has we are going to store our uh, data in our table formats. Okay, table will have a row and column structure. Okay, that we are going to store it, but it's a key value pair, so it looks like a relational database and structured format, but it's not like that. It's not working like that. Okay, so and then it has items are actual our key value values, key value data pair, and then it has attributes are our in our JSON data structure, we can consider as a keys. Okay, that is our we are considering as a attributes in DynamoDB. And then we had already talked about primary key. Primary key, it will help you to identify the uh, your data in the particular unique data. It will help you to identify that in DynamoDB. There are two things we can consider in the when we are setting up the primary key. First one is a partition key, and second one is the like sort key, or we can consider as a uh, composite key. Composite is the combination of prime partition key and then sort key. Okay, so and then another one is the secondary index. Also we can generate it. Secondary index will allows you to query the data using attributes other than primary key. Okay, so there are two types of secondary keys. It's there. One is global secondary index, and another one is local secondary index. So okay, the global secondary is allow querying on any attribute and can have the different partition key and then sort key from the base table. So that is the global secondary key, and then local secondary key is allowed you to querying different sort keys, but most use same partition key as on the base table. We can use it in the same base table. Some other some other attributes we can set it as a key rather than using partition key and partition in key and then sort key. Also we have it. Other than if you figure out some of the fields will help you to improve our database performance, we can set it as a local secondary key. That is the one thing we can use secondary index. And then another than the consistency base, because it's a distributed system, right? So and then it's also supporting multiple availability zones. Okay, so we want to make sure our data should be consistent in all the regions and everything, so that also we can configure it. Okay, so it supports basically two consistency mode. First one is strongly consistent mode, and another one is eventually consistent. Okay, strongly consistent, that basically it comes with the default eventually consistent. Okay, and then even eventually consistent, we can expect some delay in the data in various regions, so that we can expect that strongly consistent. It will make sure the data should be available at every time, and then like all the regions we can expect it. Okay, so that's also we can configure it. So yeah, so the next one, other than the basic key concept, it provides some other services also, which one is a DynamoDB accelerator. It's a kind of cache service. Okay, so it will store your queries and scans of your DynamoDB items. So it will help you to improve your query performance. So like we don't want to do any changes in our code level. Okay, so it will help your like this service will help you to it will work as a cache server. Okay, in our database layer. Okay, and then we can microseconds latency for cached data we can expect it. Like I don't need to do any code changes, and then 5 minutes our cache data should be available in our accelerator service. Okay, so this one service they are providing, and another one is DynamoDB streams. The streams are nothing, whatever actions you are doing in your DynamoDB table, we can trigger some events. Okay, so it's a continuous process of it will do some other operations. So for example, in an order table, if new order inserted, okay, some payment processing will initiate. Okay, so in that use case we can use DynamoDB streams. So ordered stream of notification of the item level modification. So what kind of operation, create, update, delete in the table happen, we can trigger some other functionalities. We can do that. Destination can be anything. We can trigger the following services. We can trigger Lambda function or a Kinesis data stream, or like Kinesis client library applications. That's also we can set it as a destination. Okay, so that service also we can trigger. Okay, and then the data retention, like that means how long our data should be available, like 24 hours. our data should be available in the stream service. Okay, so this is another service they are providing. Okay, now we are going to discuss about the demo part. Okay, so okay, in this part, okay, in this one, so we are going to build RDS, like DynamoDB table with the help of AWS CDK. Okay, and then we are going to build. We already have it. We are going to discuss about it. We are going to discuss about. We have a four Golang functions. Okay, which uses AWS SDK. Okay, and then through that SDK we can communicate with this service. DynamoDB service, we can do perform order management operations like a create order, read order, update order, delete order. These performance we can do it. So here we can see the difference between AWS CDK and the SDK. AWS CDK will help you to create the infrastructure. Okay, AWS SDK will help you to communicate and then do operations with your existing infrastructure. So that is the difference between these two tools actually. Okay, so now let's reshare my screen again, and I will share the code actually. Yeah, I hope now my screen is getting visible to you. Okay, so in the previous session we discussed about how to build the uh, create the CDK application. We discussed about okay, so like this will be our entry file. Developer series go will be our entry file. Okay, so here I'm just, these are the boilerplate code, like the main, this is the boilerplate code. Here we are returning account, like our AWS account from our AWS CLI, which we configured in our system. Okay, so it just return the environmental variables. Okay, and then this is the entry main dot file. It create the stack in our CDK application. This is our stack code. So here it just return the stack object. Okay, here I'm just creating DynamoDB table. That's it. Okay, so in the configurations I set the table stack name, table name, what is the partition key I'm going to use it, what is the sort key I'm going to use it. So my partition key will be order ID, and then my sort key will be my order date. Okay, so this is everything. The constant variables I configured here in the config folder, and then developer series.go in the DynamoDB. Here I'm creating the DynamoDB and mention my table name, and then I'm configure my partition key here, and then my configure my sort key here, and then the building mode I'm going with on demand capacity. Now I don't use the provision mode. Like in the provision mode we have to mention like the read write capacity units, RPU and CPU, RPU and WCU. We have to configure it. Sorry, I'm mispronouncing it. Like RCU and then WCU, that we have to configure if you are choosing provision mode. Okay, the normal pay per request mode we don't want to mention. Based on the demand, based on the workload, it can easily scale up. Okay, and then the removal policy, so it will help you to remove this table from the code, CDK code. So that I'm configured here. Okay, so we are going to deploy the table now. So first CDK synth, it will create the CloudFormation template for your CDK application, and then CDK deploy. Okay, now our CloudFormation template will be deployed there. So okay, so meanwhile, while deploying this one, we will just go through the four Golang functions which going to perform order management operations like create order, delete order, update order. That we, in here you can see in the functions folder, you can see like a insert, record. So these are individual Golang projects. Okay, so it has their own required packages and everything. Okay, so this is the main file. Okay, now the DynamoDB is declared. That's fine. So we will check that later. So we will just go through the functions now. Okay, here I install AWS SDK. Okay, through the SDK, I can connect with my DynamoDB table, which is created by CDK. Okay, so I'm performing insert operation, put item here. Okay, I'm creating the object, DynamoDB object, and then what are the items I'm going to insert that I'm configured here, and then I'm iterating the loop, and then I'm inserting the data here. Okay, so once it's created, data will be added there. So and then like yeah, so this is the insert query. Now let me share my screen again. I will just show you the AWS, the DynamoDB, which is we created. Okay, so this is the AWS console. So here the tables we have it. So this is the orders table we have. Okay, so I think there is no records. So now we will, yeah, there is no records. Now we will, let me share my screen, reshare the screen to the code, and then we will execute the Golang functions for create the CRUD operations. Okay. Mm. Yeah, I hope now the VS Code is sharing now. So now let's run the insert like cd functions, cd insert record. So for executing this code, we have to run go run dot. So it will run the main.go file. So it says successfully item inserted. Okay. So now if we want to query that we can do, or we can just go and check the console. So now there are two records has been added here. Okay, now let's go back to the VS Code. So now let's perform read update. Okay, so here read is nothing, just like using AWS SDK. I'm doing the query operations. Okay, I default set the values, and then the timestamp. So the based on the keys, I'm querying orders table. Okay, and then it will return, and then it will return the data in the pretty format, like pretty JSON format. It will return. So that we are going to do. Read go. Yeah, so this is the record. We see that, and next function, let's check the main.go. Okay, so in the main.go, we are going to update the quantity. Okay, in the orders table, in update record function, we are going to set the quantity uh, to a value from 2 to 3. Okay, so that we are going to do. Update record, go and yeah, so it says I successfully updated item. Let's see the console. Yeah, so now the quantity we can see it's changed to 3. Okay, now let's go back and check the VS Code. So the last operation we are going to do it delete a record. Okay. So the delete record, it's just deleting the record, deleting the first record from the tables. That is what it's going to do. Delete record, go run dot. So it says successfully deleted the item. Okay, now let's go and check the AWS console. Yeah, so the first order ID item has been deleted. Okay, so this is uh, the order management applications we have. Okay, so these are the operations we can perform. Uh, this is the way, like when you are building the application. Okay, so you are going to communicate with your DynamoDB. So like you are going to build your DynamoDB with CDK, and then you are going to communicate with your DynamoDB through SDK. This is how we have to do it. Okay, so these are the individual functions. These are the not Lambda. Okay, these are not Lambda. In the next, in the next, just a second. Let me share my screen. Okay, share my screen to code base. Yeah. So these are the individual separate Golang function. Okay. So in the next session, we will discuss about how to convert these Golang functions into the Lambda code. Okay. And then how to convert these functions into the serverless application, and how to integrate with the API gateway. That we are going to discuss about it. Okay. In the next session, we are going to discuss about how to build the entire the serverless application, which has API gateway, Lambda, and then uh, DynamoDB for order management system. This is what we are going to discuss about in the next session. Yeah. Okay, guys. Yeah. Thanks. That's it for this session. So we will see you in the next session. Yeah.